The world of professional sports now masquerades as a science fiction film. Billions of dollars, millions of tons of steel. Its new skin is a brutalist fusion of raw concrete and bleeding-edge technology. These are no longer just stadiums. They are presented as engines designed to transform entire economies, with individual project costs capable of dwarfing the national budget of a small country. A massive gamble. But do these colossal investments ever justify their price? Before the systemic macro projects, we find a critical failure point at the individual level. In Nashville, a $2.1 billion stadium project nearly crushed itself, forcing engineers to find salvation not in steel, but in chemistry. The core problem was weight. A solid, fixed roof on a structure this massive exerts immense geological pressure. The ground itself becomes the point of failure. At the same time, a $100 million injection of public funds created immense political pressure. Every dollar, every square inch had to be justified. The initial design of a monolithic roof threatened to sink the entire project before a single beam was laid. The solution came from a polymer, a synthetic skin, ethylene tetrafluoroethylene, ETFE. This is not glass. This is a high-strength film stretched taut across the stadium's superstructure. It weighs only 1% of a comparable glass facade. 1%. Yet it can withstand 400 times its own weight. The material is self-cleaning, its non-stick surface shedding dirt and debris with every rainfall. And critically, it is translucent. Blinding sunlight punches through the 12,000 square meters of polymer, feeding the living turf below. This eliminates the need for mechanically complex and costly retractable grass trays. It saves a fortune. The polymer skin does more than just provide cover, it performs. The entire system is engineered for efficiency, earning a LEED Gold certification for sustainability. Its vast surface becomes an active collector, channeling 100% of the rain into the stadium's circular water system for irrigation and sanitation. From a localized battle over material science, the scale explodes to systemic overload. In Manchester, engineers are tasked with cramming a $2.6 billion megastructure into a paralyzed urban hub, forcing a radical reinvention of the stadium itself. The project is for Manchester United. Capacity, 100,000 seats. The club is saddled with over $1 billion in debt. Active railway lines box in the site, making conventional expansion impossible. This is not just construction, it is urban surgery. The solution is a masterpiece of suspension engineering. 200-meter steel masts drive deep into the ground. A network of high-tensile cables is pulled taut, gripping the structure. The massive roof floats above the arena, suspended over the tracks without a single internal column. But its most aggressive feature is not structural, it's psychological. The roar of 100,000 voices is captured by the roof's precise geometry, then focused into a dense, coherent sound wave. It's not just noise, it's a calculated acoustic weapon, engineered to exert maximum psychological pressure on the opposing team. This is a city-shaping enterprise, projected to create 92,000 jobs. The return on investment is a projected $9 billion injection into Britain's GDP. But even the largest budgets are powerless against the laws of aviation. In Cairo, a $180 million project faced an absolute physical barrier, forcing engineers to completely invert the logic of construction. The site for a new stadium sat directly under the flight path of the Sphinx International Airport, an immovable obstacle. Civil aviation rules forbade any tall structure. The stadium could not go up, so it went down. Engineers embraced a radical solution: negative excavation. They sank the pitch and the entire first tier of seating deep below ground level, carving a massive crater into the earth. As you descend into the stands, the air changes. A wave of saving coolness washes over you, a sudden escape from the heat above. This is the physics of thermal mass. The ground itself acts as a colossal natural insulator, pulling heat away from the structure. The result is a temperature at field level up to 10 degrees Celsius cooler than the surface, a stadium cooled by the planet. Faced with an unbreachable ceiling, the project's survival depended on looking underground, an architecture of necessity born from a hard limit in the sky. From the subterranean mines of Egypt, we rise to the surface, straight into the epicenter of the ice storms of New York State. At Highmark Stadium, nature is an enemy to be defeated not by avoidance, but by brutal physics. The challenge is absolute. For a fan on the 50-yard line, the air temperature is negative 20 degrees Celsius. Fierce winds sweep off Lake Erie, a relentless assault of polar air. But the wind never reaches matches them. Engineers stacked the grandstands more vertically than in any other NFL stadium, creating a sheer physical wall. A polar wind smashes against this concrete barrier. It shatters into turbulence. It dies before reaching the seats. The air on your face is still cold enough to crystallize your breath, but a strange warmth spreads across your skin, a direct heat that feels like sunlight on a winter day. This is the project's central innovation. Instead of attempting the energetically impossible task of heating the open air, a canopy of high-intensity radiant heaters beams infrared waves directly onto the spectators. The energy bypasses the air and is absorbed by the people. Heat the person, not the atmosphere. And deep beneath the field, a hidden system works in silence. A network of tubes, a vast subterranean circulatory system, pulses with hot glycol, a mechanical heartbeat under the turf. This ensures the playing surface never freezes, preventing the ground from becoming as hard and unforgiving as concrete. The total cost for this climate fortress is $1.7 billion, a price paid to lock the franchise in for the next 30 years. This is not architecture as shelter, it is an aggressive physical shield, engineered to wage a direct war against the climate. While some engineers build brute force walls to shield fans from the wind, in Hangzhou, China, they turn the destructive kinetic energy of a typhoon into a free tool. The Hangzhou Sports Park sits directly in the path of storms roaring in from the coast, a region where nature's power is an annual certainty. The challenge here is not to withstand the force, but to dismantle it algorithmically. The solution is embedded in the building's skin, a flowing facade of vertical louvers, designed with fractal geometry by Zaha Hadid architects. Each panel is unique. Every angle and curve is calculated by a parametric model, designed to meet the wind, fracture its kinetic power, and break a single destructive gust into thousands of harmless eddies. Outside, the typhoon howls, a wall of sound and pressure. Inside, that same energy becomes a gentle, calculated breeze circulating through the concourses. It's a passive ventilation system born from chaos. This complex houses a main stadium for 60,000 spectators and an arena for 18,000, but its most astonishing feat is invisible. The entire superstructure of these colossal venues was assembled from prefabricated steel and concrete components, a giant puzzle pieced together with millimeter precision in just 24 months, a world record. This is not a system designed to block nature. It is an aerodynamic algorithm written in steel that forces the storm to ventilate the building for free. The payoff is millions of saved watts, no longer needed for mechanical ventilation. But even the most brilliant algorithms are powerless when engineering moves to the systemic level. It encounters the most viscous resistance of all: the state apparatus and the overlapping jurisdictions of Washington, D.C. This is the battle for the new Washington Commanders Stadium, a $3.7 billion vision. Its biggest obstacle is not physics, but a dense fog of political warfare. The oppressive, airless atmosphere of government offices stands in direct opposition to the light-filled, breathing space the engineers have designed. The project's fate is tangled in legislative deadlocks and national security restrictions. Here, the laws of politics deform architecture more than the laws of gravity. The engineering centerpiece is a massive, translucent polymer dome. It is designed to solve a fundamental problem of covered stadiums, keeping a natural grass field alive. A sunbeam strikes the polymer skin. The infrared spectrum is rejected, blocked completely. Only the precise wavelengths of photosynthetic light filter through, feeding the high-performance turf below. This selective process slashes the need for artificial lighting, cutting energy consumption by 30%. The structure is an optical instrument on a city block scale, yet the entire $3.7 billion plan, including 6,000 residential units, can be erased by the stroke of a single pen. A legislative veto. This is the ultimate paradox. A transparent dome born from opaque political deals. But inside, the engineering performs one final, radical transformation. The stadium's acoustic geometry is not fixed. For an NFL game, the panels shift to amplify the roar of a professional crowd. For a college tournament, the structure adjusts its resonance for the unified chants of a student section. The internal architecture physically shapeshifts, tuning the roar of the crowd on demand. In Washington, megaprojects are halted by living politicians. In Rome, corporations enter a desperate battle with the dead. Here, every wrong move with the drill is not just a construction error, it is a budget catastrophe. The task is to build a new stadium for football club AS Roma. The problem is the ground itself. How do you drive foundations for a modern arena when the earth beneath is a protected archaeological site? The first geological surveys reveal the scale of the challenge. Structures from the 2nd century, ancient Roman villas, water cisterns. Every meter of soil is a potential time capsule guarded by law. Construction stops, the project freezes. The solution comes from technology turned against itself. Ground-penetrating radar, or GPR, is deployed across the entire site. In real time, it scans the subterranean layers, painting a digital map of the buried empire. This is not for demolition, this is for avoidance. Engineers use the most advanced tools available only to ensure they destroy nothing. The past dictates the blueprint. The result is a delicate high-stakes dance. A drill bores downward. A signal from the GPR. The machine stops. The pile is rerouted. A monolithic grandstand, the Curva Sud, is designed to hold 25,000 screaming fans. A single unified structure engineered to balance on a forest of support piles, each one carefully placed to weave between 2,000-year-old walls. The radar pings another anomaly deep underground. The drills fall silent. On the surface, the commercial ambitions of a modern club hang in the balance, waiting for a verdict from the ghosts of an empire. From the ancient ruins of Rome, we move to the ruins of the modern era. In Barcelona, the destruction of one's own past is now cynically called circular economy. The project is Espai Barça, a 1.5 billion euro gamble to transform the largest stadium in Europe into a new commercial machine. The target is not just renovation, it is total replacement. The core challenge is a conflict of materials. A concrete skeleton from 1957 must support a 21st century ambition. Heavy machinery claws into the stands. Jaws of steel bite into concrete, releasing the choking dust of 60 years of history. The famous third tier is pulverized on site. This is the detail they celebrate. The old stadium, ground into gravel, is poured directly into the sterile foundations of the new one. History, literally buried by progress. The objective is to seat 105,000 spectators under a single continuous roof. But the original pillars cannot support a conventional structure of that scale. The solution is an engineering masterpiece of denial, a tensile structure, the largest of its kind in the world. High-strength steel cables are stretched across the stadium, creating a net, a system designed to float. At its heart, a massive tension ring groans under immense force, holding the entire web together with minimal contact to the old frame. Stretched across this net is a 30,000 square meter photovoltaic membrane, a high-tech skin covering an area larger than 4 professional football pitches. This isn't just a roof, it's a power plant, an architectural statement, a new identity, all to generate 347 million euros in extra revenue each year. The club boasts of reducing its carbon footprint, a claim built on the rubble of its own heritage. But while Barcelona grinds down its own concrete for 1.5 billion euros, in Liverpool, corporate ambition erases a UNESCO World Heritage Site from the map. The project's foundational act was an act of burial. To build a new sports icon, engineers had to destroy an old one. They pumped 480,000 cubic meters of sand, dredged from the sea, directly into the Bramley Moor dock, a 19th century industrial artery, a volume capable of burying entire city blocks. It was an irreversible transformation. The price for this new coastline was immediate and global. In exchange for an £800 million stadium, UNESCO stripped the city of its World Heritage status. A cultural demotion justified as economic regeneration. The historic brick base of the docks is now just a pedestal for a fortress of steel and glass. Its aggressive form wrapped in a zinc aluminum alloy to fight the corrosive sea air. An old port dies. A global franchise is born. But the structure's most critical design feature isn't the anti-rust coating. It is the south stand, a sheer wall of sound engineered for one purpose: psychological dominance. It looms over the pitch at a hostile 34 degrees. All of it. The £800 million budgets, the hundreds of thousands of tons of sand, the erased heritage, begins with one frightening thing: a soulless digital simulation. The process starts here, not in the dirt and dust of the physical world, but in the cold, sterile space of a server farm. These are the new drafting tables. AI-driven generative design tools run thousands of potential futures, optimizing for everything except memory. The chaotic, unpredictable energy of a city is fed into the machine. It returns a blueprint, logical, inhuman. We see the result on screen, a flawless fly-through of a stadium that looks more like an alien landing site. Each surface is pristine, every shadow is calculated. There is no grit, no rust, only the unnerving, dead silence of a world built from code. This digital ghost is then given a budget and a workforce, tasked with replacing messy reality with the clean lines of the render. This method is now scaling up, laying out entire new megastructures and urban plans across North Africa. It forces the question, who is actually building these machines? Is it the engineers on the ground or the algorithms for which we are just anonymous dots on a traffic flow analysis? The simulation becomes the goal, the map becomes the territory. A future built from data, for data, perfect, calculated, empty.